So, good afternoon, everyone. So, my topic for today is the types of artificial light sources. So, the types of artificial light is the incandescent lamps, tungsten halogen lamps, gaseous discharge lamps, fluorescent lamps, fluorescent luminar efficacy, height intensity discharge lamp, blended lamps, and solid state lighting. So the first is the incandescent lamps. The incandescent light bulb or lamp is a source of electrical light that works by incandescent, which is the emission of light caused by heating the filament. They are made in extremely wide range of sizes, weights, and voltages. Incandescent bulbs are the original form of electric lighting and have been used for over 100 years. While Thomas Edison is widely considered to be the inventor of the incandescent bulb, there are the number of people who invented components and prototypes of the light bulb well before Edison did. One of those people was a British physician, Joseph Wilson Swan, who actually received the first patent for a complete incandescent light bulb with a carbon filament in 1879. Swan's house was the first in the world to be lit by the light bulb. Edison and Swan merged their companies, and together they were first to design a bulb that was commercially viable. An incandescent bulb typically consists of a glass enclosure containing a tungsten filament. An electric current passes through the filament, heating it to a temperature that processes light. Incandescent light bulbs usually contain a steam or a glass mount attached to the bulb base, which allows the electric contacts to run through the envelope without gas or air leaks. Small wires embedded in the steam support the filament and or its lead wires. So this is the picture or this is a picture of the major parts of the incandescent light bulb. So this is mo ni siya mga parts sa bulb. So the bulb use is to require no external regulating equipment, have a very low manufacturing cost, and work well on either alternating current or direct current. They are also compatible with a control device such as dimmers, timers, and photo sensors, and can be used both indoors and outdoors. As a result, the incandescent lamp is widely used both household and commercial lighting, for portable lighting such as table lamps, car headlamps, and flashlight, and for decoratives and advertising light. So next is tungsten discharge lamp. Tungsten halogen lamps are similar construction to conventional gas-filled tungsten filament lamps, except for a small trace of halogen in the filled glass. So, tungsten discharge lamp is the light output from the discharge lamp is generated by the flow of current in an electric arc between two electrodes through a gas and a metal vapor inside a sealed glass bulb or tube. So the halogen gas reacts with the tungsten that has evaporated, migrate outward, and been deposited on the lamp wall. As a quartz envelope also reaches at a temperature of about approximate 250 Celsius, the halogen reacts with the tungsten to form tungsten halide, which is freed from the wall of the lamp and migrates back to the filament. The halide compound reacts to the filament where temperature approximating 25 Celsius occurs the tungsten and halogen to dissociate. The tungsten deposits onto the colder portion of the filament, and the halogen is free to continue cycle. So mercury and sodium are the most common metal vapors employed in a discharge lamp. So this is the picture of the tungsten halogen lamps. So this is the parts of the bulb. Next is the gaseous discharge lamp. Discharge lamp. The discharge lamp are one of the reliable source of artificial light energy, which fundamentally works by converting electric energy to the light energy by ionizing gas particles. Discharge lamp gained popularity in the mid-20th century. The best part of discharge lamp, it can produce lights of different colors due to its working principle. It's cheap, long-lasting, and can be used for a number of applications for a period. These discharge lamps are even used in aircraft vehicles, but due to the advent of technology, they have been replaced with CFL bulbs and leads. So thus discharge lamp is classified into three groups. First is the low pressure discharge. Second is the high pressure discharge. Next is the high intensity discharge. So the low pressure discharge is the low pressure discharge lamps. The working pressure is the much less than the atmospheric pressure, like the fluorescent lamps and sodium lamps. They produce 200 lumens per watts. One advantage of low pressure discharge is they have long lifespan. The low pressure discharge lamp requires the ballast to create a high voltage. Ballast fundamentally work on the principle of inductance. The voltage across the inductor is directly proportional to the product of inductance, and the rate of change of current will increase. Next is the high pressure discharge. The working pressure of this lamp is much higher than the atmospheric pressure. Different categories are there in high pressure discharge, such as metal halide lamps, high pressure sodium lamps, and high pressure sodium mercury lamps. Next is a high intensity discharge. The high intensity discharge lamps are very efficient as compared to pressure-based discharge lamps. They have a long lifespan and can save a lot of money, energy, and the high intensity lamps use an arc array to produce intense light. For this, they need high voltage. They need ballast just like fluorescent lights. The ballast helps to build up the high voltage. So next is so this is the picture of discharge lamp. This is the parts of discharge lamp. Next is the fluorescent lamps. Fluorescent lamps are the large family of light sources. So familiar man sa mga fluorescent lamps, no? So common siya na ginagamit. Fluorescent lamps, electric discharge lamp is cooler and more efficient than incandescent lamps. There are three main types of fluorescent lamps: cold cathode, hot cathode, and the electroluminescent. Fluorescent lights can be used in many applications: industrial, commercial, and residential. So, sa kung ingon ganina, fluorescent lamp is common siyang ginagamit sa tanan, sa sa balay, or commercial building man na siya, or residential building. So next is the The fluorescent luminaire efficacy. A luminaire is a light fixture of fitting an electric device used to create artificial light. And luminaire efficiency is the ratio of light output emitted by the luminaire to the light output emitted by lamps. Luminaire efficacy describe the efficacy of the entire luminaire, include the light source, ballast, luminaire luces. So, a luminaire is the light fixtures of fitting an electric device used to create artificial light or illumination by the use of electric lamp. Luminaire efficacy is the light output of entire luminaire divided by the total power consumed by the lamps and ballast, equal to the lamp efficacy multiplied by the light output ratio of luminaire. So ballast or control gear is a part of a control equipment, a fluorescent or discharge lamp used to establish the current. The older traditional main frequency ballast can consume up to 20 to 25% of the total lamp current. A modern electronic ballast working a high frequency consumes about 30% less current and can be used to regulate or dim the lamp output. So this is the sample of fluorescent luminaire lamps. So muna siya ang sample, and the next is the high intensity discharge lamp. High intensity discharge lamp or HID lamps provide a very bright light, and the major types of HID lamps is a mercury, sodium, and metal halide. HID or high intensity discharge light bulbs and lamps are a family of gas discharge arc lamps which create light by sending an electrical discharge between two electrodes and through a plasma or ionized gas. An additional gas is generally used, and this gas serves as an easy way to classify the major types of HID lamps: mercury, sodium, and metal halide. These lamps are known for their high efficiency at turning electricity into light and their long rated life. HID lamps require a ballast in order to generate the initial surge of electricity needed to start them and to regulate their power during normal operation. Where did it came from? The basic technology for the gas discharge lamp has existed for over 300 years, and these same principles also guide innovations in other lighting types such as fluorescent and neon. The invention of gas discharge lamp is generally credited to Francis Hosbe, an English scientist who first demonstrated the technology in 1705. At the time, the lamp was filled with air, but it was late discovered the light output could be increased by the filling the lamp with noble gases such as neon, xenon, argon, or krypton. Modern HID technology has further increased light output through experimentation in gas mixtures and improved electrodes, but the functional basics of the high-intensity discharge lamp remain the same. In modern lighting usage, the HID lamp functions by sending an electric arc between two tungsten electrodes which are housed in the arc tube, usually constructed of quartz. The tube is filled with an amalgam of gas and metal salts. Next is the blended lamps. Blended lamps consist of a gas-filled void glass bulb internally coated with a phosphor. They contain a quartz high-pressure mercury discharge tube connected in series with a tungsten filament, which acts both as an incandescent light source and as current limiting device. Blended lamp as an incandescent filament and a high-pressure discharge tube are arranged electrically in series. And the inventor of blended lamps is Alfred E. T. Glennie and Johannes A. G. M. van Vliet. These lamps consist of a gas-filled void glass bulb intercoated with a phosphorus. They contain a quartz high-pressure mercury discharge tube connect in a series with tungsten filament, which acts both as an incident light source and as gas current limiting device. They offer a combination of high luminous flux and good color rendering. MLR lamps include an internal reflector. The outer bulb is filled with a mixture of argon and a percentage of nitrogen. ML lamps emit spectrum composed of a continuum from the incident incandescent source and line spectrum from the high-pressure mercury sources. Blended light lamps cannot be dimmed. The self-blasting ML lamps are in a direct retrofit in luminaires for incident lamps, incandescent lamps. So this is the sample of the blended lamps. Next is solid state lighting. Solid state lighting is amongst the most energy efficient and environmentally friendly lighting technology. SSL has already reached a high efficiency level at ever decreasing cost. Additionally, the lifetime of LED lamps is several times longer than discharge lamps. SL technology is evolving fast, which can bring many advantages to the lighting marketplace. However, there are still some market barriers that are hindering the light cost-effective potential of energy efficient lighting from being achieved. These